If you work with any kind of electronics, you're up against an invisible enemy that can zap your components dead in a split second. It's called Electrostatic Discharge. Today, we're going to build a complete ESD-safe workstation from scratch to make sure that never, ever happens to you.
So, here's the game plan. We'll kick things off by understanding what ESD really is. Then we'll cover the single most important idea behind all of this, grounding. After that, it's hands-on. We'll assemble the workstation, connect it to ground, and, crucially, test it to make sure it works. We'll wrap up with some best practices to keep your setup safe long-term.
All right, so what is this invisible threat? Well, it's electrostatic discharge, or ESD. You know that little shock you sometimes get when you touch a doorknob? That's ESD. And while it's totally harmless to you, that same little zap is like a lightning bolt to a sensitive microchip, and it can cause total, permanent damage you might not even see.
Now, a lot of us think we've got this covered. You know, you put on your ESD wrist strap, you're grounded, you're good to go. Problem solved, right? Well, is that really all there is to it?
Here's the kicker, and this is what so many people miss. It's not just about the static on your body. If you have components just sitting on a regular non-conductive surface, they can build up their own static charge. So when your grounded hand comes along and touches that component, zap! The discharge happens from the component to you. The end result? Same thing, a potentially fried board.
And that leads us to the real philosophy behind a truly safe workstation. It's not about just grounding yourself. It's about making sure that you, your work surface, and your components are all on the exact same page, electrically speaking.
So the whole goal here is to create a system where everything shares one single common ground. When there's no difference in electrical potential between you and the thing you're about to touch, there's literally no way for a static discharge to happen. It's really that simple.
And this diagram shows our whole system perfectly. You've got the table mat where the action happens, a floor mat for you, and a wrist strap keeping you connected. And look, notice how everything, every single piece, routes back to that one common ground point. That's the secret sauce. This is exactly what we're about to build.
All right, enough with the theory. Let's get our hands dirty and actually walk through building this workstation step by step.
First things first, we'll start with the foundation, the ESD table mat. Just lay it flat on your workbench, making sure the little connection snaps are somewhere convenient. Now, take your common point ground cord and give it a good, firm press to snap it onto one of those connectors. Here's a nice close-up of that connection. It's a simple, secure snap. This is the very first link in our grounding chain, connecting our main work surface to what's going to be our central grounding hub.
Next up, let's get you connected to the system. Grab your wrist strap's coil cord and plug its banana plug right into one of the open jacks on that ground cord. Then snap the other end to the wristband. And listen, this part is absolutely key. Make sure that band is worn nice and snug right against your bare skin. It won't work properly over a sleeve.
And these pictures show those two connections perfectly. On the left, you see the banana plug going into the ground cord. And on the right, there's that final snap connecting the cord to the band itself. Just like that, you and the mat are now electrically linked. Now for another layer of protection, which is especially important if you're standing or moving around your bench, we're going to install a floor mat. And it's the same deal as the table mat. Lay it out where you'll be working and connect its own ground cord to one of the snaps. You can see that connection happening right here. This cord is now going to join up with the cord from the table mat, and both of them are headed to their final destination, earth ground.
Okay, this is without a doubt the most important step of the entire process. We've connected all our stuff together. Now we have to give all that potential static electricity a safe, easy path to get away from our workstation and into the ground.
But before we even touch that, a really important safety warning. We're about to work near an AC outlet. If you are not a qualified electrician or have any doubt in your mind about what you're doing, please just stop and call someone who is. Your safety is number one. Don't take any chances.
So the standard way to do this is to use the center screw on the faceplate of a regular AC outlet. That screw is tied directly into your building's earth ground. All you do is remove that screw, place the little metal ring connectors from both the table and floor mat cords over the hole, and then put the screw back in and tighten it down. That one screw physically connects your entire setup to ground.
And there we have it. Our workstation is fully assembled and connected. But here's the question. How do we know for sure that it's actually working? We don't guess, we test it. The way we verify this is called continuity testing. All we're doing is checking to make sure there's a good, solid electrical path from every single part of our setup.
The surface of the mat, the wrist strap, everything, all the way back to that earth ground screw. You can use a multimeter for this or a special surface resistivity meter.
Now, when you test, you're not looking for zero resistance. In fact, that would be dangerous. All these ESD grounding cords have a safety resistor built right in, usually about 1 megaohm. It's there to protect you. So a healthy, correct reading should be somewhere between 1 and 10 megaohms. That's high enough to be safe for you, but low enough to bleed off any static charge nice and slow.
Okay, having a grounded and tested bench is a massive win. But a truly safe environment, or what we call an ESD protected area, involves a little more than just the bench itself. So let's quickly cover some best practices.
Think about other static generators. A regular office chair can build up a huge charge. Your own clothes can too, especially if they're synthetic. That's why things like ESD-safe chairs and special lab jackets exist. If you need to walk around, heel grounders keep you connected to a grounded floor. Even the cleaner you use matters. Regular cleaners can leave an insulating film. And finally, just keeping the humidity in the room between 40 and 60% makes a huge difference in preventing static buildup in the first place.
And this one is a big one. Please do not store your expensive, sensitive chips in that regular pink or white packing foam. That stuff is a static generator. It's an insulator. You have to use proper conductive ESD-safe foam, which is usually black or dark gray. It basically creates a little protective shell around the component, shielding it from any outside charges.
So you did it! You have a fully operational, tested, ESD-safe workstation ready to protect all your hard work. But it does raise another question, doesn't it? Now that your bench and everything on it is safe, what about the tools you're bringing into that safe zone?